Okay, solving proportions. The first part's easy. Just cross multiply and divide. So 4 times 6 is 24, and then 24 divided by 24 is 1. You can put a 1 right there, and that makes sense because 4 times 6 is 24, 1 times 6 is 6. Okay, next one, I take 7 times 45, and then divide by 9, you get 35. So put 35 above the E. Okay, and that makes sense because 9 times 5 is 45, 7 times 5 is 35. Okay, now if I get a fraction, that's no biggie. I just take a half times 5. So 1ABC2 times 5 takes me to 2.5, then divide that by 3. It's 5/6, okay? That's your F value. Okay, then here you take 7 times 9/16. Then divide by 1/8, and that gives me 31 1/2. Okay, now with ratios, you don't want that. You're going to want to hit second, ABC equals, and that's 63/2. This whole unit, you don't want those mixed numbers. It's all about ratios. Okay, now, number 18, okay? It's not a number, it's an example, okay? Okay, a lever is an example of a simple machine. A lever is a rigid bar that is free to turn about its supporting point. The supporting point is called a fulcrum. And there's a picture of a fulcrum right there. So there you see the lever right there. Levers have a great many practical uses. Scissors, shovels, and bottle openers are examples of levers. There are 3 classes of levers. A diagram of a first-class lever right here is shown. F1 and F2, those are at the end. Those are called your forces. D1 and D2 are the distances, okay? And the fulcrum's right there. You can see it right there. It's a distance from the force at the end to your fulcrum, and then the force here to your fulcrum. Using the given values in the table, compute the missing values. Now you're given this proportion right here. Okay, it's called a proportion when you have 2 equal ratios. Okay, and that's F1. I can't really get my computer to do fractions very well, so it's F1 over F2 equals D2 over D1. Now why is it like that? More on that later. Okay, but for now you just find the missing value into your proportions. So let's figure out the first row. So F1 is unknown. I'll put X. F2 is 300. Now D2 is 7 and D1 is 10. Why that's inverted, we'll discuss that later. Okay? Why it's F1, F2 and not D1, D2, that comes up later. Okay, so I cross multiply, divide 300 times 7 divided by 10. That's going to be 210. So the force of 1 is, the F1 is going to be 210. Okay, now the next one, I set up another one. So F1 is going to be 80, and F2 is unknown. So X, D2 over here is 4 over 10. Okay, so I take 80 times 10. Divided by 4, and that's going to be 200. So 200 is the force there. Okay, then the next one. So F1, okay, F1 is 50. F2 is 125. And then D2 is 5.5, okay? And that's going to be X right there. So I take 125 times 5, ABC1, ABC2. Then I divide that by 50, okay? 13 3/4. When you're figuring out this on a story problem, you can put the mixed number. Because I have a mixed number here, why can't I here? So 13 3/4 feet. By the way, when you're finding the force, it's labeled pounds. Make sure you include the labels. Okay, and then the last one, really pretty easy process. So F1 is 65, under it F2 is 200, and then D2 is unknown now, and D1 is 6. So I take 65 times 6 divided by 200. That's going to be 1.95. You can write the decimal. I don't think they really care what you're doing there. So the distance there is 1.95. Okay. Now, one thing you'll notice, okay, if F2 has the higher force, it has the lower distance, okay? The higher the force, the lesser the distance, okay? The lesser the force, the greater the distance. And you can clearly see that. I mean, in all these problems, F2 has a greater force, but it has a shorter distance to the fulcrum. Okay, now the next one, you got a couple easy problems. It says the compression ratio compares the volume of a cylinder at BDC, that's bottom dead center, to the volume at TDC, that's called top dead center. If the compression ratio is 9.273 to 1 and the volume at TDC is 5.482 cubic inches, what's the volume of BDC? So ratio means you set up a proportion, and that's your ratio. So it's going to be 9.273 over 1. Now, that is the ratio of BDC to TDC. So BDC, bottom dead center's here, top dead center's here. Okay, and the reason that's top bottom, because you got to read it, because it says the volume of a cylinder at BDC to the volume at TDC, and there's a compression ratio. Okay, now I got to figure out where to place the 5.482 cubic inches. Well, it says that's the volume of TDC, so we're going to put it right here, 5.482. X right there. And then the BDC is the answer. Okay, so I cross multiply by 9.273 times 5.482. I got 50.83. I'm around the nearest hundredth. It would stay 3 because there's a 4 there. Okay, so 50.83. It says what's the volume, and that's cubic inches, so inches to the third power. Now the next one, we're gonna set this up a little bit differently. A car was filled than what you're used to in some of the algebra classes you've taken, because in this class it's going to be needed, not just the way you think it should go. A car was filled with 15 gallons of gas at a cost of $31.89. A van pulled up to the same gas pump and put 12 gallons on its tank. How much did the owner of the van have to pay for the gas? I have these units underlined for a reason, gallons and dollars, okay? And what you're going to do with your ratio is a little bit different than algebra. You're actually going to put the gallons on the same ratio, gallons, gallons, because otherwise if we don't, we're going to be screwed when we go forward. And then money, 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 okay? Now, I put my gallons, I got 15 and 12. Now the dollar amounts, okay, there's something you have to analyze before you just start throwing them in here, okay? Write those two words, gallons, comma, dollars. Now when I pay for gas, if the number of gallons I buy go up, the cost is going to go up, okay? So that means it's directly proportional, okay? That means we want to match them up across. Now, we're going to come across some problems where one unit goes up while the other goes down. Then we match them up diagonally, okay? But they're both going up. They're both going in the same direction, so we match them up across, okay? So since $31.89 is with 15 gallons, I mean, that tells us 15 gallons cost $31.89. We're going to put that directly across from the 15. Now, there's going to be problems coming up where one goes up, the other goes down. Then you're going to match them up diagonally, okay? But for today's assignment, if they're both going up, which they do, the more gallons I buy of gas, the greater the cost, okay? We match them up that way, okay? And then X right there, So if you cross multiply and divide, you get the answer. So you got 12 times 31.89 divided by 15. That's going to be $25.51, which makes sense when you look at it. So again, you want to match up your units. You don't want to go gallons ever in this class, okay? You want to match up your labels, top, bottom, and then fill in the labels that you have. The two, you're always going to know what one of them is, because like I had two values for the gallons. I just throw them in there. But then I really got to be cognizant of what's happening with the units. One goes up, the other goes up, okay? So you match them up across. Since that matches with the 15, it's in the same sentence, it goes across.